All right, so here's some help with the back page of the day one trust calculations video. We already did the front. Um, and remember, on every problem, you only have to do the problem if it's statically determinate, which means 2 times the number of joints equals the number of members plus reaction forces. Okay, so you should always check that first. It's worth a shot. So on this one, I count the joints 1, 2, 3, 4. So we got 2 times 4. And we're checking, it's really a question mark. We're checking, does that equal the number of members, which are your beams? 1, 2, let me mark 1, 2, 3, 4, 5. Plus the number of reaction forces. And remember, every time you have a roller, it is 1 force on it, and every time you have a pin, you have 2. You have horizontal and vertical. Now, usually the reaction forces are easier to see for people's brains on bridges, because you can imagine the bridge is weighing down on this roller, and the roller's reacting by having a vertical force. Most people are cool with that. So you'd say this is a reaction force on joint A in the y direction, right? Most people are cool with ray. This one has 2 forces because it's pinned here. Not only is it holding the bridge up, which is a reaction force on joint D in the y direction, reedy, but it's also keeping this bridge from rolling left to right. Like if a strong wind came or a pterodactyl, this is more like an albatross hits the bridge sideways at 100 pounds force, this will actually react. I know I usually draw it in, but do you see how this is moving left? I know that this joint will be pulling right to keep the bridge from from sliding that way. If you draw it wrong, it's not a huge deal. You'll figure it out because you'll get a negative answer later. RDX, redux. That's a chemistry term. All right, so most people are cool with those reaction forces. What they struggle with are if you mount it to the wall. So picture the walls right here. Okay. So I was saying to people in class, picture this like a shelf. And if you put something really heavy on the shelf, if you've never done it before, the shelf will pull out of the wall up here. Or you can picture this like if you were hanging on this structure, you were trying, you hanging on it kind of makes a rotational force this way, like a clockwise rotation. So it's going to try to force this thing into the wall. Joint D will be pushing really hard on the wall, and joint A will be trying to rip out of the wall. If there's a nail here and a nail here into the wall, right? Then basically because of this rotation, joint D is going to push in, joint A is going to try to rip out of the wall. Well, if joint D is pushing in, guess what the reaction force is? It's pushing back. The wall's pushing back and saying, no, I don't want you to push right through the wall and put a dent in it. Well, that's a reaction force on joint D in the X direction. Okay, and up here, since it's trying to pull out of the wall, your wall is going to be pulling back. It's going to be fighting the other way. It's going to be like, hey, I'm hanging on as best I can. And this is Rax, good old Rax, reaction on joint A in the X direction. And then last but not least, most people can figure, since gravity and whatever this force is trying to pull down, then the reaction force will be to pull up. These sideways ones are tough for a while. We'll get used to them. Technically, if you turn it sideways, I remember somebody asking in class, could I just turn this sideways and do it? Pretend it's a bridge. Yeah, I mean, look, you're holding the bridge up. You probably would miss the direction on this. But I think you'd get the left and the up here. You might have gotten the wrong direction. But once again, there's a trick for that. And you'll see later. You just get a negative. If you ever get a negative answer, you just drew your arrow wrong. All right, so does 2 times 4 equal 5 plus 3? Heck yeah, it does. Which means I can do this Problem. So now it's time to think about wrenches. Remember, I always get to pick my pivot point, and I always pick the one that's on the pin because it means I don't have to calculate rax or ray. So basically, after you determine that it's statically determinate, you have two steps. You first want to make sure you check the clockwise moments are turning forces, equal the counterclockwise. And then you just make sure the ups equal the downs and the lefts equal the rights. Okay? So here's what we're going to do. What do we do? Oh, clockwise turns. So if I consider this my pivot point, and I think of this 200-pound weight here, it's trying to rotate my bridge this way. So that is a clockwise, yeah, that's the way a clock goes. That's a clockwise rotation. And if you don't see the wrench, right, this is my pivot point. Remember, wrenches always go around pivot points. It's kind of one of these like angle wrenches. Now here's the key, and I made these two distances different on purpose because I want to make sure you're getting good at, it's always force times distance, but it has to be the perpendicular distance. So this is 5 and this is 6 feet. Which one of them is perpendicular to the direction your force is pulling? Well, if my force is pulling vertically, then my horizontal distance is my perpendicular one, so 6-foot wrench, which is kind of weird. But what that's saying is the amount of mechanical advantage you would get out of this weird angled wrench is the same as you would get if you just had a straight wrench that didn't have this downspout. So anyway, that's my pink wrench that's twisting clockwise. What's that being fought by? Remember, I don't have to test rax or ray because I picked this as a pivot point. So the only thing that this twisting force is being fought by is the wall is making it try to twist back that way. It's trying to keep it from moving. So I'll draw that in with an orange wrench, right? And that is just the wrench to here. So this orange wrench, it goes from this force, so I'm going to have my redux RDX, I don't know that force yet, times its distance, and perpendicular, see how this is a sideways force? I want the vertical distance. Okay, so now I do a little division. The feet are going to cancel with the feet, and RDX must equal whatever 200 times 6 divided by 5 is. Oops, wow, that's crazy bright. 240 pounds of force. So I already know RDX. Now I just have to find rax and ray. And the way you find, once you find one, it's like a puzzle's kind of unfolding in front of your eyes. Once you find rax and ray, you know how I said my twisting forces clockwise have to equal my twisting forces counterclockwise? Well, now you go into your total forces vertical have to equal your total forces, or your forces up must equal your forces down. And your forces left must equal your forces right. Oh, geez, forces right. So, it keeps things well in the world. So my ups have to equal my downs. Well, when I look at this picture, I only see one down, and I only see one up. See, Ray is fighting this. So my 200-pound down force must equal my only up force. Oops, I forgot to write that on camera. My 200-pound down force has to equal my RAY. Oh, that was easy. And I only see one right and one left. I just found out that our dx was 240, right? Well, that's my right force, 240 pounds. It must equal my left force, which is RAX. So now I know all my reaction forces. It's just 240 in the other direction. And this is 200. So basically, your ups equal your downs, your lefts equal your rights, all is right in the world. And we now know all our I call these external forces, because they're not forces that happen on the beams, they're forces that are applied to the bridge. Okay. Similarly, we can do this one. I already drew the pictures. I'll help you with the wrenches, but then I want you to finish it. So this one's a little tougher because you're going to have several ups and one down. You're going to have one left and one right, so that won't be that bad. But I want to help you set up the clockwise and counterclockwise. CCW for counterclockwise. All right, first of all, we can do the 2 times the number of joints. 1, 2, 3, 4, 5 must equal the members. 1, 2, 3, 4, 5, 6, 7 plus the reaction forces. 3. Boom. It works. I can do it. Okay. So now let me help you with the wrenches. Remember, I always pick my pivot point to be this pin, because then I don't have to calculate these two. And now, here's what's weird. Look at my forces. If this is my pivot point, see this force? This force is trying to make my bridge spin that way. Because look at it. Imagine you had like you don't do the diagonal, you do like the vertical. Imagine I had a wrench like this, and I pushed sideways on it. If I push sideways, it's going to try to make the bridge spin, or if a bird hits the bridge that way, it's going to try to make the bridge spin down into the ground, kind of that way. Okay, there's another force, RAY, is fighting that. Because if you think about it, if RAY is pushing up and I draw a wrench, hopefully you can see the yellow. Yeah, you can. I draw this wrench. RAY pushing up on a wrench there would be trying to spin the bridge that way. And lastly, I have this force in the middle at E, like a 200-pound motorcycle just sitting on joint E of the bridge. Well, if I draw that, kind of hard to see because my colors are overlapping, but that force is trying to spin my bridge this way, down. So I have 2 forces going counterclockwise, fought by 1 force clockwise. So you have to be careful when you set this up that you know ray times its distance, which is 4 feet and 5 feet. Oops, 9 feet. Ray times 9 feet equals the other 2 added up, because this one force is fighting both those down forces. So ray times 9 feet equals 100-pound force times, remember, perpendicular is the height, so 6 feet, plus, and this is the first time we've had multiple spins, plus a 200-pound force times its perpendicular distance. Since it's a down force, I want this 5 feet. And now you can do the calculation from there. And once you know ray, you can figure out RDY, because all your ups have to equal all your downs. And once you find your lefts, you can make them equal your rights. So the hardest part is the twisting forces. And then the last one, hopefully you can tell you wouldn't drive on that bridge, but it's just to double check that you always want to check this statically determinant, or you may end up wasting time. You may see no numbers on there, but I just want you to check your static determinant thing, so you notice when it fails. Alright, so that's the help on the back page. Finish up that problem, and I will check it later. Alright, bye people.